Okay, I think we'll get started. So we're going to build off the last two labs, and there really are prerequisites for this one. You'll want to understand this clever lookup table method using the return literal to working capability of the PICs, and then the DAC setup. So we're going to do a digital to analog waveform. We'll make a sine wave and a triangle wave. Very simple setup, similar to the last labs. We'll just have an indicator LED here on RA2, and the real action here will be happening on RA1, which will be our DAC output. All right, let's take a look at what this is, how we're going to build this. Okay, so we've got the PIC set up here. It's in place now. Up here is where do the programming. So with the, as before, with the DAC, you can't run that while your PIC12F1822 is plugged in. So I'll just move back and forth here between the powered position just with some USB power, and then up into the programming spot here for the PIC12F1822. I'll be using a PIC12F1822 to be programming this. It's running right now, and it's got a triangle wave or a sine wave, and we'll see here that it's not perfect because we have just 32-bit resolution, but not too bad for a kind of a quick and dirty sine wave. Pretty good. So I'm going to pause the video here and set up the screen towards the scope. Okay, so let's go back to here. Okay, so we can see here we've got a sine wave. Not perfect, as I mentioned. Let me zoom in on it. Zoom in on it. We see not too bad there for a sine wave. All right, so I'm going to pause this video back again, and we'll look at the code. Okay, so let's get the code. So it'll again be at my GitHub page, and we'll look up the PIC12F1822, and we will grab the DAC retlw or return with literal lookup table. So we'll grab this. Then we'll start with our file, our MP lab already set up. So I think lab 7 was the last place where we walked through right from the beginning to get here. So if you're just coming to us from this video, then you'll want to get yourself to this position. And so I'll let the other videos do that for us. So I'll just paste this in here. And let me also reduce or remove the power and move the PIC up to the programming position and reintroduce the PIC12F1822 again. So again, PIC12F1822 is what is programming this. All right. So top stuff always as before. This is just the configuration bits, where to start, where the program counter starts the program, and then here's the main part of the code. This is the stuff that we keep fixed. So we have seen this now for a couple of videos. This is setting up our analog, and again we have to turn RA0 to an analog. And then the other thing that was tricky is that we have to actually make that an input, even though it's an analog, it's a DAC output. So that's kind of a tricky part. And then the DAC 0, this just sets up the DAC itself. And then let's move now into the main loop. And now we're going to connect with the pulse width modulation lab where we used a lookup table. And so that's what's happening right here is we are creating an index of 30. It's going to be actually 32 entries, so 0 through 31. And we're going to store that into register B3, and that's kind of arbitrary. I just use that because I use B0, B1, and B2 for the delays. And so we'll stick that in there as our index register. Then we move into the DAC waveform function. And so we're going to move the contents of B3, whatever that is, as that's changing. Right now it's 31, and into the working register. And then this bit is just a precaution. This just ands it with the complement of 31 so that it gets, it ends up making sure this never goes beyond 31, because if it does and it goes beyond your lookup table, it doesn't work, and it's hard to know why it doesn't work. So important to match this index with how many entries you have in your lookup table. I've got to comment it out here, the triangle wave, so that we're looking at the sine wave. Let me put this back in and comment out the sine wave, and now we should get a triangle wave when we come back. Then this is going to call this function here. And again, what this does is it takes what's ever in the working directory. So in this case, it's going to be 31 to begin with, and adds that to the PCL counter, the program counter. So that's going to first kick us here to the 32 away, starting our count at 0 from the current position of the program counter. And then we'll work backwards. So the functions are always written backwards, or you don't have to, but that's the way I like to do it. And notice they peak here at 31 because we only have a 32-bit DAC. Okay, that comes back. We need to go back to the DAC bank, which is bank 2, and move the contents of the working register, which is whatever it came back from here. In this case, it would have been 0 the first time through, and send that to DACon 1. So that's going to be the actual output in voltage. Then this is just to give a little indicator electrode. So we're port A. I always use port A for bank 0. I just remember that's bank 0, and set the LED there. We could add a delay to slow down the waveform, but I'm going to just let it run full speed here. And then we decrement here now the index register. So that's going to take us down by 1, and then it's going to go back up to here, move now 30 into the working register, and then that will take us to this position after it calls triangle. And that'll just keep looping through, and it'll keep walking up this until we get to 0, in which case, when the index is down to 0, that will skip the go to the DAC wave, and then we'll go back to the main loop and reset our index. So it'll just repeat and repeat and repeat. Okay, so let me build this, make sure it builds, and then I will now write it to the chip. Looks like it did. Okay, so now what we'll do is, you could probably hot swap this, but I'm going to just make sure, be extra careful, and remove the power from the PIC, remove the PIC itself, and put it in place into the circuit. Again, very simple circuit. This is just indicator LED, the 470 ohm resistor, protection resistor there. This is the scope. These are leading to the scope, so this is ground, and then this is the DAC output. So we anticipate now, when I put the power, that we should get a triangle wave. So let me pause the video, and before I put the power, and I'll move the camera back over to the scope. Okay, we're back at the scope here, and I will now introduce the power. We get triangle wave here. Let me bring that out. Again, not perfect, a little bit of issue right at the peak, but nonetheless, still pretty good triangle wave. All right, so that is it for creating a waveform with the DAC.